Hello everyone, welcome to our very last step for today's lab section. This step is really common to everyone, we all are going to have to do it, and I really didn't technically have to prepare a video for it, but I decided to do it anyway just to facilitate that you could access this material asynchronously. So I know that a few of you might take more or less time to go over the previous steps, so this just ensures that we are all able to follow kind of along but also at our own pace. So we're going to be doing an intro to JASP. Again, very quickly, JASP is the statistical software that we're going to be using to generate our data analysis. JASP is a very user-friendly software. It is very easy to use. It's going to be very helpful to describe our data, to obtain descriptive statistics, to run any kind of statistical tests, and also to obtain very nice looking figures that you might use to either describe your data or describe the results of the data analysis that you have decided to perform. This introduction is going to cover three main steps. So first, we're going to focus on how to load our data to JASP and how to make sure that it is set up correctly. Then we're going to talk about, in general, how can we use JASP to obtain some general descriptive statistics. As you probably know by now, a descriptive statistics refers to the area of statistics that is focused with just summarizing the data that I have collected. So it's just telling me about the properties or the information that I have collected through my different questions in my survey. We are going to focus on two dimensions here. So first, we're going to describe our participants. And as you can imagine, we're going to do that using the responses we gathered from our demographic questions. And we're also going to be describing the variability contained in our variable score. So we're going to be doing those, and we're going to be generating some nice little visualizations. Then on our next step, we're going to be taking a glimpse at our possible relationship between our variable 1 and variable 2 scores, and we're going to be doing that by means of obtaining a scatter plot. So let us go with our very first step. Let us load our dataset on JASP. For this, we're going to be loading our dataset in a CSV format. Very important that you remember this. So we're going to have to download our toy dataset that we have been working on Google Sheets, download it as a CSV, and then load it to JASP. And then just making sure that variables are correctly identified before we proceed to our actual analysis. So let us do it. So I'm going to go back here to my standard reverse-coded toy dataset. Again, this is the one that I have been using, but you should be working with the toy dataset that corresponds to your own inventory that you use for variable 1. We are going to download this, so you might recognize that this looks exactly as we left it for our last video when we talked about how to compute the variable 2 scores. That's perfectly fine. You would note here that we have here, again, registered for each of the participants that I made up, the responses they gave across all 5 demographic questions, and all the questions related to variable 1 in green, variable 2 in purple, with a couple of reverse-coded questions, such that at the end, I have computed an individual score. So for each participant, I have computed a score for my variable 1 and a score for my variable 2. So I'm going to be downloading this dataset, clicking here on File, Download, and then I'm going to make sure to select the comma-separated values format, so the CSV format. I'm going to do this. I'm going to give it an informative title, so please preserve the title, the standard title that I gave these toy datasets. The only thing that I require you to do is that at the end, please just write underscore and then your first name, just like that. And I'm saying this because this CSV file that you are just downloading now, that has already covered all the previous steps, this is the very first file that you're going to have to submit for this lab assignment. So once we do that, we go here and open JASP. We are already welcome to our software. We go here to the 3 bars here. We go to Open. From our computer, we browse. We go to our downloads folder in my case, and in here I have the file, the CSV file that I just selected. So I double click and I open it. And I'm going to make this bigger so that we can take a look at it. And so the first thing you would note is that we are able to visualize our dataset in a very similar way to what we had for Google Sheets. There are a couple of differences that remain. So the very first one perhaps is that the column names still correspond to the actual questions as participants saw them, but in here they are shown completely. So this is an extremely wide column, which I personally don't really like. So I'm gonna try to make it look prettier by editing each of my variables here. So I'm going to do that by going here to the column name and double clicking. This is gonna open this menu. where I'm going to be able to see the long name of the question, which corresponds to the questions as participants saw them. But then I'm going to change for a shorter name. So let's say that instead of keeping that whole question as I presented it, I just want to identify this variable in a useful way. So I just want to remember that this is the age variable. That's perfectly fine. Then second, I'm going to make sure that my column is being identified correctly. So JASP has 3 main column types depending on the type of variable or the type of information they contain. So we had either scale columns, ordinal columns, or nominal columns. You might remember this from a lecture. So in this particular case, age is a numeric value, so we know that this could either fall under the scale or the ordinal categories because there is an order, a natural order. So a person that is 19 years old is indeed younger than a person that is 20, 21, 22, or whatever. So there is an order, so it could be considered, or it could be inserted as an ordinal value. But I also know that this is actually an interval scale. And why is that? Because the distance between a person that is 19 and a person that is 20 is the exact same distance between a person that is 21 and a person that is 22. So there is a constant interval across my different levels. Therefore, I might as well recognize this value, this variable as a scale type of variable. So I'm going to do this. And we can see here that our changes have already been implemented. Then we go to our next variable. So again, we have here the full question. And let's say that I want to change it again. Let me do this practice with you again. So I'm going to go here, double click the title here. And now instead of having the long name, which is okay, I still want to preserve that for future reference. I just want this variable, this column to be shown as gender. However, the responses that I have recorded are labels, right? So these are labels. These are just words that correspond to the categories that people have identified themselves with. So I'm going to notice that here, JASP has already identified this correctly as a nominal type of variable. So that is what it is. It's just a name. It's just a label. So I'm going to preserve it like that. And I keep moving forward. Then for my next 3 demographic questions, we can see that something similar might apply. So all of them are also nominal variables. All of them also include some kind of labeling for which we don't particularly care for their values. It's not a number, it's just a label. So I'm going to keep them as nominal. They are all correctly identified. We can see here by the little icon, which is the same as here. And the only thing I'm going to do is I'm going to take the time to just give it shorter names. So I'm going to do that real quick right now. Alrighty, so we can see here that we have already successfully renamed our demographic variables here. So now I have shorter names that are going to be much easier for me to interpret and to call out in the future. Now we go here over our questions. And so the first thing that I want to know is that these questions are input as responses on the Likert scale. So in this particular example, this corresponded to a scale that had values, or that showed participants a scale with values between 1 and 5, where 1 was strongly disagree and 5 was strongly agree. In that case, hopefully you already have it clear that all these values are ordinal, in the sense that, yes, there is an order. Yes, somewhat disagree implies a less degree of disagreement than somewhat disagree. There is a natural order there between my categories, but the particular distance between these categories is not constant, and it's not really something that I can measure. So it's not clear for me whether the psychological difference between saying that I strongly disagree and somewhat disagree with something is the same psychological distance between saying that I somewhat agree or I strongly agree with something. So we are going to check that all of our responses given by participants for the different questions in our scale are correctly identified as ordinal, and that seems to be the case. Next thing I'm going to do is just going to, for the sake of it, just going to give it shorter names. So what I'm going to be doing here is pay attention. Alrighty, so the only thing that I just did is I went over each one of these columns and I renamed them so that it was easier to take a look at all of them. So now I have identified which are the questions that pertain to variable 1 and variable 2, so B1, B2. And then I have given it a little index to indicate whether they pertain to the first, second, third, or whatever question. Here with the acronym RC, I identified the reverse coded questions, and in the immediate column, the one that says correct, I have indicated that this is the one that contains the actual flipped values that we have to use. And here at the end, we have our 2 columns that we worked on the last step. that just contain the scores for my variable 1 and the scores for my variable 2. Alrighty, so we are ready to go. Oh, and finally, we know that these two scores are correctly identified as scalar variables. And why is that? Well, so first of all, it's because these are the results of numerical operations. So in this case, we are better treating them as continuous or a scalar value. Alrighty, that completes our very first step. Then we are ready to go to step number 2, where we have to obtain some general descriptive statistics. And we're going to do this in terms of 2 dimensions. First, we're going to be describing our sample using the demographic information we collected. We are going to be taking use of 2 main tools for visual representation, which are pie charts and distribution plots or bar plots. So the only thing that I would like you to consider is that pie charts are particularly useful to represent variables that have few categories. We're going to emphasize this in a second. Whereas distribution plots or bar plots are typically recommended for variables that have many categories. You might also choose to present your information in a table. After we have done this, we are going to move on to the description of our variable scores using violin plots or box plots. So we go back to JASP, we click here on descriptives, and this is going to give us access to our next window. I can close this now. I'm going to make this a little smaller, and now I have here the manipulation area for my descriptive statistics. So again, the first thing I want to do is describe my participants. And I was told that I have to generate a pie chart, which are preferable for variables that have very few categories of response. So from the variables that I have here, it seems like gender might be the best fitting one. So I'm going to call in gender. Oh, I noticed that we have here timestamp. We don't really care about this because this is not going to be used at all. What I did is I called in, or I took my gender variable and I passed it to this area here. Notice that automatically JASP gives me this table that is describing how many of the values that I obtained in that for that column are valid and how many of them were missing. So I have no missing data. That makes perfect sense. Because this is a nominal value, we don't have any numeric descriptive statistics here because we cannot take the mean of a bunch of labels or the standard deviation of a bunch of labels and so forth. So we're going to move along to where it says basic plots. And in here, we're going to click where it says pie charts. And automatically, JASP is going to create this nice looking little pie chart here that represents the distribution of males to females in my population. So here, just by pressing a button, I have now been able to describe my dataset. Alternatively, we could also have depicted this information by going all the way down here to the tables sub-menu and clicking here on frequency tables. And that will let us produce this automatic table where we have identified which are the response categories for this variable. So in this case, we only had 2 response categories, females and males. And here we have the frequency for each of these 2 categories. So 15 people that identify as females and 5 males. Here we have the percentages corresponding to these frequencies and so forth. We have no missing data and a total of 20 observations. Now, this frequency table works fine. But one of the things that I wanted to be critical about, or that I wanted to prompt you to be critical about, is what is the most efficient way to convey what I want to transmit to my reader without wasting too much of their time. So in this particular case, this is just a variable with just 2 categories of response. There is really not a lot of use in portraying a frequency table of this kind. It might be much more easy. I just have to take one glimpse at this particular pie chart to already get an idea of what my data looks like. So for variables with very few response categories, we might choose to portray your information by using some simple visualization like a pie chart or just even a sentence within your course research report. Now I'm going to move to a different type of representation. So I'm going to take out my gender here and I'm going to now click here my ethnicity. Now look here, because I have still selected the same boxes here, that it's giving me the same output. Now notice here that again, this pie chart that I have here looks kind of nice because it has a lot of little colors and all that. But because I have many categories, it's kind of difficult for me to interpret it. It's kind of difficult for me to get a grasp of how many African American students I had in my sample just by taking a look at this area here. In this case, where I have many categories of response, then it does become useful to have a frequency table that tells me specifically how many instances of each of my category groups I had. So now I know that there was only one African American student in my sample, which is something that might not be super evident from looking at here. Or the same here, it kind of looks like the majority of people are either Latino or Asian, but it's very difficult to get a grasp of whether these two areas are the same. So now if I look at my frequency table, I can see that there actually are. But humans in general are not very good. We are not very good at judging areas just by looking at them. So when we have many categories of response, pie charts are not really recommended. Instead, we would recommend to work with distribution plots. So I just click here where it says distribution plot, and I have here a nice little bar plot that is showing me the proportion of the frequency or the number of times that each of the possible categories happen. And notice here what I just did with JASP. This is very neat. You get to adjust the size of the figures by just grabbing this here. This automatically fixed the clunkiness on how the labels were presented. So this is actually pretty neat. And again, this visual representation seems to be much better than the one we had with the pie chart, right? Now I get to get an idea of which are the most common groups within my sample. I also get an idea that they are actually the same size, or that I have the same number of people identifying with both ethnicities with the same frequency. And I also know that, yes, I have very few African Americans in my class, but I also know how many of them. So that is something that we can do here. All right, so that is all for our very first step. We have discussed cases in which we can use the pie charts. Hopefully it is clear now why we prefer to use them when we have variables with few categories of responses, and distribution plots when we have many categories, as well as frequency tables. Then we're going to move up to describing our variable scores. So now I'm going to be conducting another description. So if you don't want to erase what you have done, which is kind of what I accidentally did, you can just click here on descriptives, and it's automatically going to open a new, kind of like a new menu here. So now I have, this is for my ethnicity variable. If I move here, I am now talking about a different variable. I can open this. I can even give it a different name. So now this is going to be... So now I gave it a different name, variable 1 and variable 2 variability. So now I'm going to be calling in here, as I just said here, the final scores that I computed for my variable 1 and my variable 2. So again, right for the get-go, we get this kind of like automatic descriptive plot or descriptive table that is just telling me how many of my responses were valid and how many were missing. So we have no missing values here. And because the variable 1 and variable 2 scores are imported as scale variables, we do have information about the mean score observed across my variable 1 and my variable 2, and their standard deviation, as well as the minimum value calculated and the maximum value calculated, and the same goes over here. So this, for example, would be a table that would be very useful for you to use when you describe in your course research report the variable 1 scores and variable 2 scores that you obtain. Then if I move along here, we see here that we can add more information to this table. So we can include the specific percentiles or quartiles that we have. So remember that a quartile corresponds. So we have 3 quartiles, actually 4, but the last one is a bit redundant because it's just the 100th percentile, and that is just the entirety of the data set. So the quartiles allow us to identify the values for which we have 25% of my other dataset falling below that. So if I were to order all of my scores for variable 1 from lowest to largest across all my participants, 25% of my participants would have a score lower than 16. 50% of my participants would have a score lower than 18.5. This is also the median of my variable scores. And the 75th percentile would be indicating that 75% of my participants got a score lower than 20.25. And then the remaining quartile would just be the 100th percentile. But again, that would just mean that 100% of my participants got a score equal or lower than just the maximum score observed, right? So that is not really informative. We don't typically include it. For variables like this that are scalar and that have a lot of variability, we are going to be using two things. Well, first, we could take a look at the distribution plots. Takes a little while to compute, to take a look at how the distribution of the scores that I computed across my both variables look like. This is perfectly fine. This is something that you can totally include in your course research report. But we had already covered an example about distribution plots. So I'm going to move to something a little bit nicer. So I'm going to go to customizable plots, and I'm going to show you how to produce a box plot. So I click here on the box plot element, and this is automatically generating one box plot for each of my two variable scores. Perhaps if I move this, yes, we can now see them both on the same space. So it's easier to compare them. Notice here that we can add this little element here to draw the density line around the box plots. And actually, if I go back here to my distribution plot, which generated these two histograms here, I can also click here on my display density option. And this is going to show an approximation to the density. We don't have to worry about this a lot. The only thing that I wanted to show you is that this line that has just been overposed or overlapped on top of my histogram is describing the exact same line that I have here. So the violin plot is nothing much than a nice little representation, a mirror image of the density curve or the density being fitted here to the values that I observe across my variable 1 scores and my variable 2 scores. So this right here is exactly this curve that we have here. And as you may note now, so box plots are useful tools that allow us to describe our data. So they allow us to identify key values. So they allow us to identify the median of our the median value of our set of variable scores. It allows us to identify the 75 percentile. So I know that 75% of my data points here fall below this value, and my 25th or 25th percentile over here. So I know that 25% of my values fall below this value here. And the same thing goes for my variable 2. So for your lab assignment this week, you would have to include these two plots and a little description of what these two representations are telling us. So just tell me what the median is, just tell me what the 25 and the 75 percentile are, just a general interpretation. All right, so we are almost done. Only thing that we have to do is now try to approximate or try to explore to get a first glimpse at the possible relationship between our scores for variable 1 and 2, and we're gonna do that by creating a scatter plot. Now, hopefully, you should already have seen that there is an option for that right here on the customizable plots menu. We just got to scatter plots, and this is automatically generating our nice little scatter plot showing the relationship between the scores that I have for my variable 1 and the scores that I computed for my variable 2. So I have this nice little scatter plot. I am showing here the density plots. So these densities here, this and this one here, are the exact same curves that I had here. This is just showing me, in addition to the correspondence of the variable 1 scores and the variable 2 scores, their marginal distribution. Alternatively, we could show those as histograms, but those looks a little ugly, so I'm gonna keep the density. Oh, and you can see that you can manipulate that for both axes individually. And that's what we have here. So just to make sure that we all know how to interpret a scatter plot, I'm going to make this bigger. So a scatter plot is a specific type of plot that helps me visualize the relationship between paired data points. What does that mean? Each of these dots is a given participant in our toy dataset. Each of these dots is showing me the relationship between the score they got for the variable 1 and the score they got for their variable 2. So kind of like as Cartesian coordinates, I am locating a point here in this plotting space that represents the relationship between the scores they got across my two variables. And ideally, scatter plots should be used to portray or to get a first idea of what would be the relationship between my two variables. So in this case, we have this fitted line here that suggests the relationship between my two variables here. What this line here is suggesting is that there is not really a very strong relationship between my two variables, meaning that for very large and very low values of my variable 1, I expect to find roughly the same values for my variable 2. That is what this regression line is showing. And here the opaque area is just showing my confidence interval around this prediction, around this mean relationship between my two variables. So I would be saying, if I had this data set, that according to the data set, there doesn't seem to be a very strong relationship between my variable 1 and my variable 2, at least in terms of how the two scores that I obtain behave. So again, for your lab assignment report this week, you're going to have to provide this scatter plot. You're going to have to provide an interpretation like the one I just gave you, and you're going to make up some names for these two scores. So what are two variables for which you would expect this exact same relationship? So what are two variables that you would expect to be very weakly related to one another? Alrighty, and that concludes our video for today. And the only thing that is remaining for me to cover with you here is just to make sure that we are all under the same page in terms of what you're going to have to submit for your lab assignment 5. So the instructions are already on Canvas at the end of the announcement that was just published. So for your lab assignment 5 submission, you're going to pretty much have to submit two files. The first file is going to be the CSV file that you imported to JASP. So this CSV file should already contain all the changes that resulted from following the steps for the data cleaning and data preparation practice. So for example, responses to every question should appear as numeric values and not as labels. You should identify somehow with either a color scheme or changing the name of the columns, which of your questions were reverse coded, and also identify the column in which you have put or saved the already reversed questions, or sorry, the already reversed values. Your CSV should contain no filler questions, and it contains at least two final columns containing the scores for variable 1 and 2. And I'm saying at least because, as you know, some of your inventories, so the tip inventory, for example, might require you to compute multiple scores instead of one. So please do include those. And your second file is going to be a write-up document that first is going to contain a very short description of what you did for your data cleaning. So you're going to tell me what was the toy data set that you chose to use and why. And you're going to tell me all about how you did your reverse coded question practice. Number 1, was it necessary? Number 2, how many questions there were on your data file? And number 3, how did you identify them? And finally, we're going to be taking a look at your JASP output. You can do that by either copying and pasting it. That's perfectly fine. Your JASP output should contain at least one pie chart, remember, about a demographic variable, along with a brief interpretation or a brief description of it. Then we have at least one distribution or bar plot about another demographic variable, again, accompanied by its own little description and interpretation. We should have two box plots with a violin plot, or two box plots with a violin plot overlap for the scores you computed for variable 1 and variable 2. A scatter plot showing the relationship between the scores you got for variable 1 and variable 2. And in this same write-up document, after you have shown me the scatter plot and you have given me the interpretation in terms of what does it say about the relationship between the scores in your two variables, you should come up with a hypothetical interpretation for this relationship. So if you are someone that worked with an inventory that we gave you for variable 1, you might not need to make up a name for variable 1, that is already a given, but you might need to provide a name for variable 2. So that is all for today. Thank you very much for your patience. If you have any questions, feel free to rewatch any of these videos, and please do let me know if you have any further questions. Bye!